Welcome back to Saginaw Valley State University's Math and Physics Resource Center's online tutoring videos. My name is Brad, and today we're going to be talking about a problem from Calc-Based Physics 211 about angular momentum and torque and how to calculate them. So let's start with just kind of some conceptual stuff. So angular momentum and torque, they both have rotational they're both rotational analogs of rectangular coordinate concepts. So angular momentum is the position vector across the linear momentum, and or rectangular momentum, I guess, if we're dealing with more than one dimension. And then torque is the same thing, but we replace that with force. So torque is the analog of force, and angular momentum is the analog of linear momentum. So how do we really calculate this stuff? So let's start by let's just draw a picture first off of what we're dealing with. So we've got x and y coordinates, so call that right I hat, call y j hat. And our position vectors, so we're gonna x is at 3, y is at 8. So we can see that r is 3i hat plus 8j hat. And they give us our velocity vector, and to calculate the momentum from linear momentum, right, we just multiply these components by the mass. So our p hat is going to be, what, 15 I hat minus 18 j hat. And this will be in Newton seconds, and position will just be in meters. And then, so if we want to cross R and P, so we know we've got I and J components for both of these, so we know the K hat component of this is going to be the only result from the cross product. So we can just start by writing the K hat, and then the determinant of this submatrix, where we put R first, and then we put the angular momentum. So 3 and negative 18 is negative 54, and then 8 and 15 is subtracting 120 kilogram meters squared per second in the k hat direction. And so that is what? Negative 170 kilogram meters squared per second. And the reason I round right to this position is just because I only had two significant figures at the beginning of my problem. And now we're going to do the exact same thing, but we're going to do R, not R hat, R cross F. And they tell us that F is just pointed in the negative x direction, so we've got negative 7 newtons, and we don't have anything in the I hat or in the j hat direction of this one. And then we've got 3 and 8 again, right, because our position vector is the same, and it's also in the k hat direction. So 3 times 0 minus a negative 56, so it should be a positive 56, and this will be kilogram meters squared per second squared in the k hat direction. And the other thing is to kind of think about, going back to Newton's second law, is that one thing we know, again, we're going to kind of think about rotational analogs to rectangular concepts. Force is the rate of change of momentum with respect to time. So the rotational analog of that, right, would just be to say, well, torque is the rotational, or is the time derivative of the angular momentum the same way. So for part C, in fact, it's this exact same quantity. So the torque is the same thing as just the rate of change of the angular momentum. So understanding that connection is important to answering that problem, but the big connection really to make is to understand that a lot of the stuff that you've set up in rectangular applies directly, assuming you're kind of working in the right system of measurement for rotation. So I hope this problem was helpful, and I will talk to you in another video.